Imagine the day that aliens arrive, not with a death ray, but with a rug and a new understanding of physics. Daniel Whiteson's new book opens with a wild question. What if aliens show up with a better understanding of physics, but we can't even recognize that's what they're offering? How would we react? Physicists hope that aliens might carry the product of millions, billions, or kazillions of years of alien scientific thought that would catapult us unimaginably into the future. But Daniel speculates on why we might not be able to understand even the language it's written in. Join us today for a conversation about Daniel Whiteson's new book, Do Aliens Speak Physics? And a romp through the Drake equation, the future of artificial intelligence in physics, and even the search for exotic new particles. Now let's go deep into the impossible. Today with Daniel, we're talking about his newest book, Do Aliens Speak Physics? With co-author Andy Werner. So this is an interesting book. And as you know, what I like to do is what you're never supposed to do, judge books by their covers.
Hey, book lovers, we're judging books by their covers. We know we're not supposed to do it, but into the impossible, there's nothing to it. Let's take a look and judge some books.
So I want you to take us through the title, the subtitle of this book, and the amazing illustrations throughout, but especially the cover illustration. We both forgot to bring in professorial, prerogative, professorial physicist podcaster, triple P, triple threat. Take us through the cover. What does it mean? And how did you come up with the idea, title, subtitle? Cover art.
Nice. Thank you. The title is Do Aliens Speak Physics? And the book is really asking the question of whether we can make mental contact with another intelligent species using physics. Because this is something you hear often. Carl Sagan says that aliens live in the same universe as we, and so they must discover the same laws of physics and chemistry as we. And when you see it on television shows, it's often math and physics that people begin with to make connections with aliens, because the assumption is that while, psychology and economics and biology are about Earth-based questions, physics is about the universe. And Newton told us that physics doesn't just apply here on Earth, but also in the cosmos, right? And we can see galaxies spinning and apply our laws of physics. And so there's this sort of widespread belief that physics is something we'll have in common with aliens. And I'd love for that to be true, because I want to know the answers to questions. I want to talk to aliens about physics. I hope that civilizations that have been asking these questions for billions of years have figured a bunch of stuff out, right? And they would share the knowledge with us. But it always seemed to me to be a little bit too flattering, too self-centering, to assume that the ideas we have, our descriptions of the universe, are the description. The humanity's attempt to explain the cosmos is the reality of the cosmos. So I wanted to dig into the assumptions behind that and to figure out, what do we really know about how aliens might think about the universe, whether they are, whether they have to use math, whether they'd be interested in the same things. So that's the impetus. And, it comes really from a philosophical question, which is physics, human physics, discovered? Is it part of reality, or is it invented? Is it our description? Is it the map or the territory? And that was the book I wanted to write originally. And I pitched that to my teenager who's interested in science and tech. And he was like, ugh, philosophy and physics, yawn. And I thought, oh no, this is my passion project. But then I went back.
Add in some 6-7, add in some brain rot.
Well, I decided to add in aliens. Yeah. I was like, well, why does it matter if physics is invented or discovered? It matters when we meet the aliens, when we try to have that conversation. If they have a different way of approaching explanations of the universe, it'll be quite obvious quite quickly. So I came back to him and said, well, what if it's a book about when aliens arrive and we try to talk to them about physics? Would that go well or badly? And he was like, oh, I'd read that book. And so that's why aliens are in the book. And that's why it's about whether aliens speak physics. Is physics the language that we can use to communicate with them? Is it the thing we have in common? Are you and I, Brian, just two professors in a galactic enterprise to understand the universe? Wouldn't that be incredible? But because it's philosophical, we added, and other questions about the nature of reality and the universe.
And it falls in your long tradition of collaborating with artists.
Yes.
So there's a tremendous number of artistic renderings of many different things. In particular, just the way in which Andy, I guess, illustrates it to bring out and really, make not the dumb down. I hate when people say dumb it down, but make it accessible. And so was that a conscious choice? I mean, are you ever going to write a book that doesn't have a world-renowned artist like Jorge or Andy?
I hope not. As you know, popular science has lots of different approaches. There are some books where you read it and you might not necessarily understand it, but you feel like you're in the presence of great ideas. And I think there's a lot of books out there. And some of those books, like Stephen Hawking's books, I read and I don't understand them. I'm like, how does anybody getting this? If you have a PhD in physics and it's not enough. So I think that's a different kind of experience. But my goal is to write a book where you really get it, where the ideas click in your mind. I'm not trying to intimidate anybody with impressive cosmic ideas. I'm trying to really make people think about this stuff and make them realize that these ideas are totally accessible, right? Ideas in philosophy and in physics, they are questions that people have. They're things people want to know the answers to. And the ideas, they are accessible. And so absolutely, it's a conscious choice to use cartoons because they do several things. One is they give you the impression that this is a book that you can understand because, hey, it doesn't take itself too seriously. It's got cartoons of aliens in it, right? Also, I think it's important as a sort of pacing device. Like you read something that's kind of a deep idea, then you see a joke about aliens and how they might make pizza. And it gives you a breath and it gives you a time for that idea to sink in and really settle in and for you to absorb it. And so it's a lot of fun. And also, I enjoy conversations. Yeah. They're much more interesting than lectures. And in this way, the book sort of has two voices. There's the voice of the text and the voice of the cartoons, and they play off each other and make fun of each other a little bit. So the book becomes a little bit more like a conversation than like a lecture. So that was definitely a conscious choice. And I've always been a big fan of Andy Warner's. He's done a lot of great nonfiction comics about science and about history and et cetera. So I just cold emailed him and said, hey, would you be interested in writing a book about aliens? And in my history of cold email and cartoonists, I'm 2 for 2 now. So
well, that's pretty good. Well, maybe you can help me out with Scott Adams. I don't think he's aligned with you in many ways. But what's also kind of unique about this book is embedded within it is a fiction story. Yeah. There's a lot of, and I don't want to give away any spoilers. I interviewed Chris Hadfield of the Apollo Murders and his most recent book, Final Orbit, or Andy Weir, non-graduate of UCSD. He attended UCSD, but he didn't graduate, like so many people. But he, I always say it's the hardest thing to do is to interview somebody about a fiction book because, you're forbidden to talk about it. I'm not, going to play the role of short form, one of my sponsors, this video is not sponsored by short form, but many are. I'm not going to summarize, but it's almost impossible to, kind of encounter a fiction book without giving away some of the plot lines. At least he has a lot of hard science fiction and historical events and things up until the murders. Spoiler alert, it's called the Apollo Murders. Final Orbit, you can guess what they're about. But this book has a fiction story embedded within it, and I kind of want to use that and not, to spoil it or anything like that. Yeah. I love it when people talk about, and they're talking about a movie like, Contact or Interstellar, okay, spoiler alert, like sometimes I watch Interstellar, I actually just watched it this year, by the way, and one of my kids forced me to watch it.
If it's been out for 20 years, I think it's fair to talk about
exactly. It. Matrix, I've never seen that, but it's fair game for spoiling.
Tootsie, we all know how that ends.
But I want to start off with kind of the question you asked in the beginning. Physicists hope aliens might carry the product of millions or billions or kazillions, as we know, a unit of SI knowledge, of alien scientific thought that would catapult us unimaginably far into our quest to understand the wonderful, bizarre, violent, and beautiful cosmos. Yeah. Now, do you think that there's underlying it? I often feel like embedded in the Fermi paradox is sort of a secret projection of religious overtones or, kind of godlike powers. You're kind of a savior here, right? If aliens exist, I mean, you're not saying that, but this is what a lot of physicists and lay people among us feel, that when aliens come, they're going to deliver the answers to the, humanity's final exam, give us the theory of everything, which does make an appearance here. No spoiler. But why is that? Why are people so convinced that they're going to be, far in advance of us instead of being, dolphins or slime mold or whatever? They just happen to be teleported here in some intergalactic Lorcon 7, Planet Lorcon 7's, science fair project. So why do we think that they're going to be so advanced? They're going to save us, Daniel. They're going to be our saviors.
I think a lot of people look to space, not just to aliens, but space exploration and conquest as the future, and somehow out in space we'll leave all of our problems behind. And if you've read Zach and Kelly Wienersmith's amazing book, you know that there's, a lot of projection there. And so I think people are just sort of hopeful, the same way people moved to the frontier to leave their problems behind and brought them with them. Right. And so I'm not sure that's really going to work out. But in the case of aliens, it's potentially could because, there's been a long time in the universe where alien civilization could have developed. The ingredients for life have existed for billions of years. So it's certainly possible to have ancient alien civilizations. Your question, how do we know they're going to be more advanced than us? Well, if they just exist on their planet, then who knows, right? It's just algae or dolphins or whatever. But if they arrive here, then they, at the very minimum, have technology that we don't. right? If they can cross the stars, either they have technology or patience or funds that we don't.
Long lifespans that make Brian Johnson envious.
To try to, crisscross the universe and to come here. And so that's why in the book I focus on that scenario. When aliens arrive, they have this technology. What can we learn from them? Because although I'm enthusiastic about SETI, for example, as I write in the book, I think the prospects for that kind of communication and mental contact are basically zero. I think it's
because they don't exist. I mean, I resonate with this, but to be devil's advocate or aliens advocate, because such advanced life forms don't exist, or because the universe is so capacious, we can't ever hope that they could come to us or we could get to that. Why do you say that?
I think it's not a scientific assumption. It's not a scientific statement, but I hope and assume that the universe is filled with life and that there's intelligent life out there. But I say that it's impossible for us to make a mental connection with those aliens because I think the task of decoding an alien message is probably impossible. We take our ideas, we encode them in some language. There's a translation there. You go from ideas to symbols, and those symbols are always arbitrary. Yeah. There's no set of symbols which only have one reverse encoding. And so you have to know something about the people who encoded it in order to decode it. Like when we decode human languages, right? We look for a translation that makes sense. You've decoded it correctly when like clear text pops out and it makes some sense. In the case of an alien message, how do you know what it's supposed to look like? How do you know if you translate it correctly, you would be able to make sense of it anyway? The ideas themselves are so alien.
So what do you make of these, sightings by prominent, I've had them in this very often, not when it looked as nice as it does for you today. I had a prominent fighter pilot, Ryan Graves, in here who's claimed that not necessarily he has seen objects, but that his squadron mates and others have seen it, and he has a side quest to make aviation more safe, which is admirable. But tell me, what do you make of David Grush and Lou Elizondo? He's not a fighter pilot, but it was a military guy.
Sure.
All these different people that claim that not only do aliens exist? Not only are they much more advanced than us technologically, but we have actual physical, cold, hard encounters, evidence, and not just eyewitness stuff, but circumstantial and even physical evidence. Grush claims that there's a craft with biologics within them. He said to my friend Jesse Michaels, the spacecraft has aliens in it, bodies in it. So what do you make of these people that otherwise got to very high levels of government security clearance? Or they just kind of lost it, or what do you make of it from a scientific point of view?
Well, I don't know these folks personally, but I hope that they're right. I would love if aliens were here. I would love if there were craft in our skies, they were extraterrestrial or non-human intelligence. I would love if, I would have loved if Oumuamua was a light shield. Was a light sail. I would have loved if Atlas was a probe from aliens. I'm a big fan of all that.
I want they could cover your class, or they'd go to this dean's meeting that preempted us from.
So I could sell my book intergalactically. No, so that we could learn these secrets of the universe from them. Like, what an incredible moment to make contact. Everybody's excited about that. Scientists, non-scientists is an example of the kind of things we're all fascinated by. So I want that to be true, but I also want it to know that it's true. Yeah. And for me, that requires more than just a story. And so we've heard lots of stories and we see fuzzy videos, but they all have other explanations. And the stories we hear of evidence don't come with the evidence. So a guy says he has some evidence. That's a story. It's not the evidence. So, and I'm not an expert in these things. I haven't gotten into the debunking and the debunking of the debunking. But I would love for that to happen. But I haven't seen the hard evidence yet.
Even knowing the history of, encounters between alien civilizations, between continents, it's not like when settlers from Europe came to America, they shared the, secrets of calculus or, in medieval, kind of pre-Copernican theory, right? I mean, they did a lot of bad stuff and did a tremendous amount of, enslavement and torture and warfare. And some things were intentional, some things maybe weren't, but I
think, for example, the burning of all the Mayan books was intentional.
Yeah, and that's for sure. To eliminate what you mentioned in here is a way to kind of decode. Let's touch upon one thing that I found very fascinating. You say something to the effect that language and skills kind of only evolve my interpretation, to meet the technology of the species. In other words, dolphins don't need quantum mechanics, right? Even we didn't need quantum mechanics until very recently. Maybe you do some speculative fiction. What would have happened if Einstein, knew quantum mechanics as a 5-year-old and started asking questions about that? I think it's like The Simpsons. Like Abe Simpson said to Homer, if you go back to the past, never step on a bug because you'll ruin the future. But tell me, what would it look like? Could we even communicate? What is the speaking? What are we speaking when we speak physics, as you say in the title? Yeah,
it's a great question. And you have to get into the specifics, like what do we really mean? And, humans have tried this. In the 1800s, von Littrow dug trenches in the Sahara, filled them with kerosene, wrote out mathematical equations and set them on fire, hoping the Martians would see them and go, oh, look, there's intelligent life on Earth. So, that's early attempts. And then Carl Sagan and Frank Drake with the Pioneer plaque, they made a depiction of the hydrogen atom and put it on a plaque and hoping that somebody would see that and go oh yeah, that's a hydrogen atom. And, what are the chances that aliens could really understand that? Well, I put that Pioneer plaque in front of a bunch of UCI grad students. And, this is a very easy audience. They're physics grad students. They're biologically human. They have the same culture as these folks. They had no idea what this thing was supposed to mean, right? Because the depiction...
nudie picture. We'll show a clip of the Pioneer plaque here. It's a little risque for today's audience.
But, in the corner, there's hydrogen atoms. And, that describes how we thought about the hydrogen atom for about 20 years, about 100 years ago.
Right.
And so it's a moment in our culture. It's just an example of how difficult it is. So, how would you communicate physics? You need some symbols. You need some common language. And so, I think if we just get a message, it's impossible. But if they show up, then we have a context in common physically. So we can begin with math and say here's a donut. Here's 2 donuts, and you can point at things. You can have that context. You can associate the symbols with the object. So I think it's not impossible if the aliens have similar ideas in their minds, which is a big if, for us to find some symbols and associate them with them if we share that context in common. That's why I think alien visitation is crucial to making any progress at all. If we're just sending messages back and forth across the stars, we're going to be decoding it forever and having no idea.
So, the famous 1962 essay by Eugene Wigner called The Unreasonable Effectiveness of Mathematics and the Physical Sciences. You mention aspects of that in this book. It seems like if they speak anything, remotely, possible for us to decode, it might not be physics. It might be, which is layered upon layers of partial differential equations predominantly, but it might be mathematics. So why is the book not called Do Aliens, what they speak mathematics, or do they know, calculus and AB?
Yeah, it's part of the question, right? In order for them to speak physics, they have to also speak our mathematics, and it's a fascinating component of it. And anybody who's done physics knows that mathematics is incredibly important to the way we think and express physics, but also to discoveries we make, right? How many times in the history of physics has mathematics led the way to reveal something true about the universe, from Maxwell, putting the equations together and feeling mathematically this could be prettier. There's a piece missing. There's a symmetry that's not exact here. And he, essentially proposes this new piece and then goes out and discovers it in the universe. That's math showing us the truth of physics. Or I remember as an undergrad learning quantum mechanics and seeing those calculations to 9 decimal places, and then they measure it to 9 decimal places, and having what, felt to me like almost a spiritual moment where I'm wow, this isn't just a description. This is the source code of the universe, man. This is how the universe decides what happens to an electron.
Because as you're saying it, I get goosebumps.
Yeah.
You are now them, okay? You are one of the foremost experimental physicists. You work in the LHC up the road. You work on Atlas. We work on CMS. So we've got to wrap up the interview now. These are rivals. But, as I said,
friendly collaborators.
You're friendly. Yeah. We're all in the same project of understanding Mother Nature, right, Daniel?
Me, you, and the aliens, yeah.
So how does it feel now? You are the them. You are the people now getting things to 10 decimal places. That's an awesome responsibility and awesome accomplishment. How does that make you feel just as a human being?
Oh, it's hard to put yourself back in your shoes of who you were when you were an undergrad, hoping that you could spend your life answering questions or asking questions about the universe. I feel very lucky, very privileged. Things went just the right way for me at the right time. I was in the right place, many moments, and very fortunate. So I feel grateful. But I also no longer agree with, 21-year-old Daniel about this philosophical question of whether math is part of the universe. because I've been exposed to other ideas, and there's so many really powerful skeptics. There's so many really powerful questions I don't have answers to. Like, is math more than just effective? Is it necessary? Like, it's possible that math is very powerful and it helps us think about the universe, but it could also just be a tool we use. And I read this great book by Hartree Field called Science Without Numbers. And he argues that a lot of the machinery we use in our calculations, which is mathematical, are sort of intermediate points, things that you don't need. They're helpful, but you don't need them. For example, a field, right? What is an electric field? Has anybody ever seen a field? No. A field you can only measure by its effect on particles. And so in that sense, we put these numbers everywhere in space, but do we know those numbers are really there? Does a field exist when you're not looking at it, right? Philosophical question we don't have an answer to. And he goes beyond that and he says, well, this idea of putting numbers in space, why do we need the number line at all? Right? The number line is sort of an abstraction. You have things that are like bigger and smaller, further and closer, and then you assign values to them. And so he developed a theory of gravity without any numbers at all. So his book is called Science Without Numbers. And it's not a pretty theory. Like, it's ugly, it's clunky, you would never use it. Right. But it makes the point that this thing we thought was fundamental turns out to be an accelerator. It's just useful. And, we can't go from that to like all of physics. He just did one portion of it. But for me, it really struck a tone of doubt. Like, how do we know? These things I like to believe, that math is fundamental to the universe and that aliens must also discover it. But how do I know? What is the skeptic, the scientist in me? Right. Do I have any data? Or is it just a compelling belief? Because, the history of science is having those compelling beliefs, those intuitions peeled away when you see the data. You're like, oh, wow, the universe doesn't require classical paths at a quantum level. It's crazy and insane in a way we're still trying to deal with. So I think we need to be skeptical, and we need to accept the fact that some of the things that make sense to us, that feel comfortable, that we'd love to believe, might not be true. And the book essentially is asking us, like, well, how strong are the counter arguments? Yeah. Can I make a reasonable argument against some of these assumptions to try to open people's minds to the idea that aliens might be much more alien than we expect?
Right, and completely incompatible even with our modalities of communication or comprehension. It's funny because I'm kind of going the opposite way, to turn things to my favorite subject, which is me. The opposite direction for me is that I'm wondering if there can be a one-to-one, mapping of every mathematical structure into a physical structure. I'll give you an example. Like, we teach, classical mechanics, and we know there's this concept called the Poisson bracket, where you take simultaneously the measurement of the position of a beach ball and the position and the momentum of the beach ball. And you can do those, commensurately. You can do those consecutively. You can commute those measurements. You can measure the momentum first, then the position, vice versa. So when you construct the mathematical operator of position times momentum, subtract that from momentum times position, you get zero. So that's a commutation relation that vanishes. When you add the concept of square root of -1 and a constant called Planck's constant, then in quantum mechanics, that same exact identical mathematical structure is non-zero. Yeah. It equals the square root of -1. It is so bizarre that happens. And I've, wanted to write an essay called On the Unreasonable Effectiveness of the Square Root in the physical sciences, because I think it's even more, than just mathematics. Yeah. When you invent something like that, once you have that, then you have quantum mechanics, then you have the Schrodinger equation. Once you have the concept of a four-dimensional matrix space called the Pauli matrices, you can represent spin 1/2, and that kind of gets represented as a square root of a three-dimensional operator in real space. You get the complex two-dimensional representation of the Pauli matrices.
You have quaternions,
octonions, right?
It's amazing.
So my concept is like, does everything, and I asked Terry Tao, our collaborator in the University of California system, I asked him basically, does everything in math, exist? And he basically said he doesn't know. We can't really know that. So in the book, you talk about kind of just a way of maybe describing math, science without math or something like that. You say, what if, these aliens, and aliens are proxy for just, maybe physics we don't understand. Yeah. but maybe aliens can smell electrons. What kinds of, kind of hidden, it made me think of hidden variables. It made me think of things that we used to think like, oh, we knew everything, the famous statement allegedly by Thomson, but it really wasn't by Lord Thomson, that the future of physics is in the last decimal place of 6-digit numbers or something. That was in 1899, right before Planck. Right? He couldn't be more. And I went to the University of Glasgow. I went to Maxwell's birthplace this summer. I had a Scottish tour. It was really great. But tell me,
did you have haggis?
It's hard to find kosher haggis. Yeah, I tried, but it's very hard to find. It's impossible.
I had vegan haggis when I was in Scotland.
Oh, that's kosher. Why don't you tell me? Oh man, you could have hooked me up. That would have been great. I did have some scotch, and I did play some golf at St. Andrews. That was nice. But tell me, what other kinds of things are stranger than possibly we can imagine that might preclude us from ever being able to understand the Codex Alienus or whatever it is?
Yeah, I think you hit on something there, which is how we perceive the universe. Because we know now, of course, that the universe as we imagine it, I have this model in my mind of your chair and your body and the floor here, that there's much more going on. Our senses don't reveal everything. And, we've overcome that, of course. We have technological senses now that can tell us that there's neutrinos flying through us, and there's oceans of dark matter, and there's a dark energy out there, and all sorts of stuff. And, we have a reliable way to probe the universe beyond our senses. But I think in the end, we're fundamentally limited in our understanding and in our intuition by those original senses, because we tend to translate our new technology back into the original language. Like our basis set of our minds, the eigenvectors of understanding, are our visualizations or, the structures in your head. Those come from your senses. So when we take pictures with James Webb, for example, you don't look at them in the IR, right? Mm-hmm. When you you translate them into the visual spectrum, right? And we do that with everything. You take gravitational waves and you listen to them like they're sound chirps, right? Everything gets translated back into our intuition. And so now imagine aliens. Maybe they evolved in a different setup and so have slightly different senses that suit their evolution. That, I think, also might mean that they have a different intuition. And they translate things into their intuition. And we might just not have an overlapping intuition. So things that make sense to us that we go, oh yeah, that clicks. I get it. They might be like, well, hold on a second. That makes no sense to me at all. And things that make us puzzle, they might find totally natural. And so we might end up at a place where like the explanations that we're satisfied with are incompatible, right? Mm-hmm. That we're fundamentally looking for different kinds of answers if we have different intuitive language about the universe. And I see this everywhere in physics. It's not just like shifting wavelengths, but also concepts. Like you try to explain to your undergrads, what is a photon anyway? Oh, it's a particle. Oh, it's a wave. What are you really doing there is you're taking something totally alien and unfamiliar and trying to express it as like some combination of mental eigenvectors. You're like, use this one plus a little bit of that one. And, it doesn't really work. And it doesn't work because it can't be described by those two. It's not in your mental space at all. And so that's an example of something which we might never really intuitively understand because we don't have the language embedded in our minds because of the kinds of perceptions and the experience we evolved with. And so that could be a fundamental limitation. Or it could just be that, our kids grow up and to them it makes sense, but we never get it or something as the aliens arrive.
So throughout the book, it resonates the Drake equation. And obviously, Frank Drake was a titanic contributor to a lot of what we think about when we think about SETI. Past guest and upcoming guest Jill Tarter is coming back down. She'll be in that chair in a few weeks. Yeah, she's one of our favorites. Hey, everybody. I'm usually the one that asks my guests to judge their books by their covers. But today I'm asking myself to judge my own book by its cover. My newest book, Focus Like a Nobel Prize Winner, is chock full of advice, life tips, and focus and productivity tips from 9 of the world's greatest minds, Nobel laureates ranging from economics to peace to physics, of course. It launches September 9th, which is also my birthday. I hope you'll check it out. And my publisher's gotten Amazon to run a special just for listeners of the Into the Impossible podcast. So go to Amazon and get the Kindle copy today. Talk about that, the Drake equation. First of all, give a definition for those of the audience that might not be familiar. And then also talk about you and I are experimental physicists. So what are the limitations of it? Errors, systematics, calibration. Talk about the nitty gritty details of it, but first give an overview.
Sure. So the Drake equation is sort of deceptively simple. It's an attempt to describe the number of alien species or civilizations we could come in contact with. And the structure of it is not like complicated, like, the Schrodinger equation or the Dirac equation. It's just a bunch of numbers multiplied together. But hidden in that structure is a real wisdom, because it tells you that you have to have lots of things all line up in order to have that alien communication. It starts with, the number of stars in the universe, which we now know is huge. And then the fraction of those stars that have planets, which we now know is significant. And then the fraction of those that have life on them, still totally unknown. The fraction of those that are intelligent, the fraction of those that develop civilizations we could communicate with, and then times the length of those civilizations. So it gives you a sense for like how many aliens are out there that we could communicate with. And, the multiplication of them tells you, like, if any of those are zero, it doesn't matter how many planets there are if none of them have life. It doesn't matter how much life there is if none of it's intelligent or if none of it is technological. You have to have everything line up just right to have that glorious moment of alien communication. And it's super exciting that we live now, like in our lifetimes, we've gone from having no idea how many planets there are around an average star to having measurements with uncertainties. And, those measurements like 30-ish% plus or minus 10, 20%, it's incredible because that number could have been 0.0001. Yeah. We could have been the only star out there with planets. We could be like the aberration. And now we know we're not, that we're very typical in that sense. And that many, many stars have Earth-like planets. So that's incredible. But then the next number, right? What fraction of those have life on them? We still know that's just at least one over a huge number. And it could be just one. Like we could be alone or it could be everywhere. So, but it's exciting because we're living in an era where, we're imaging exoplanets and we're measuring their atmospheres and we're learning about what's in the composition of those atmospheres by seeing the light from those stars pass through the atmosphere. It's incredible what smart folks are doing. And so it could be that in the next 10 years, we learn something much more concrete about that next number. How many planets out there have life happening. But then again, it could still just be algae in the oceans or whatever, slime molds, who knows, that are not going to talk to us. And there's something else about the equation I love, which is that it tells us essentially what we're looking for. Because we're curious about whether there are stars out there and planets out there, but really we want to find someone to connect with. We want to find an intelligent race to talk to about what it's like to be alive in the universe, right? To communicate with and get another perspective. And that's why I chose the Drake equation as the foundation of this book and then extended it because frankly, I'm not satisfied if we just get to talk to aliens because I want to ask them questions about science. Like you have questions, you've devoted your life to questions about cosmology. Hopefully aliens have figured out. So in the event that we meet aliens, I want to meet aliens we can talk physics with. And that's why I added extra terms. Already highly constrained Drake equation. I was like, no, I'm going to be pickier. I want aliens that do science. I want aliens that we can communicate with. I want aliens that ask questions we're interested in and aliens who generate answers we can understand. Mm-hmm. All of those things have to happen for my scientific fantasy to come true, where we sit down and absorb the incredibly advanced knowledge of the universe. But the exciting thing is like, it could, right? It could really happen. And so, it's a lot of fun to think about. But I think the structure of the Drake equation really reinforces how everything has to fall into place. Mm-hmm. But you also start from a huge number. And so in the end, you really just need one, right? Yeah. It's like marriage.
Yeah, that's right. Unless you're Elon Musk or Donald Trump. Yes, exactly. I do feel though that, there is often this kind of obsession with space being big. Yeah. Even Carl Sagan, had this in the movie, which by the way, it involves a non-fictional version of Jill Tarter up until they detect aliens in Contact. My dream is to get, her co-star, Jodie Foster's co-star on here. And Jodie Foster would be great too, but Matthew McConaughey's Interstellar. I mean, come on. This guy's been a great, he's got to be a science geek at some level. So if you get him, send him my note.
Oh, yeah. But next time I have a beer with Matthew McConaughey, I'll mention your name.
She's in there in that movie with Ann Druyan. I did have Ann Druyan on the show, and she's Carl Sagan's widow, who co-wrote the book. Most people don't realize that. And I said, there's this refrain throughout it. If there are no aliens, it's an awful waste of space, which is this teleological, almost, again, messianic or, quasi-theological argument that there's some purpose to the universe, which, I believe there is, but who knows? I'm not speaking scientific. I have no evidence for that. Yeah. But but in general, I make the argument that, I've been to Antarctica twice. Here is some ice water, no longer in the ice water, icy form phase, but this is actually collected at the South Pole, Antarctica.
There's some floaties in there, Brian. What are those?
Yeah, those are alien. Those are those are Klingons clinging to the bottom there. So Antarctica, when I was there, I think I was the fattest person on the count. I was like the most out of shape. There are people there that run marathons. The guy won the Boston Marathon 10 years ago. Yeah, like I'm like the least in shape person there. I mean, there's some real studs and studettes. So I'm like on that continent because, I can be like a superlative. I can be, maybe I have the best physics knowledge of anyone, although there's a lot of smart physicists at the South Pole. But you get the point. The South Pole is almost devoid of people, right? It's this huge continent. It makes up 1/7 of all continents. It makes up, I think, 5% or 7% of the landmass of the entire planet. So if you said, look, Daniel, we know the planet's teeming with life. It's even teeming with technological conscious physics. There's literally 1 million physicists on this planet. What do you think the percentage of them that live in Antarctica is? And it'll be like 0.00. Just having space is not enough, right? I've never thought that was a good argument. My friend and probably yours, also fellow Norton author Adam Frank wrote, basically there's 10 to the 24th, stars and planets in the observable universe. I'm like, well, I don't really care about a planet that existed 12 billion years ago in a galaxy that's 40 billion light years away now. So what's relevant is the space that's occupied in our galaxy. And it sounds like you might resonate with this too, that yes, the odds of life might be extremely high, but there's no evidence for it, right? So we have no evidence. So right now necessarily must be faith-based. And that's when people chime in, well, what about the eyewitness evidence? So you kind of get in this loop. And I wonder if there's a Drake equation for that. Like, for the types of kind of communication, your wish list, your teleology is different, than maybe the audience. But you make the case in the book that, okay, so let's say they do all those things.
Yeah.
Daniel's, Christmas wish list has been satisfied. They're buying your book. They're communicating, whatever. But they actually see neutrinos or gravity waves or gravitational waves. You talk about that in the book.
Yeah.
Doesn't that narrow the phase space to basically zero? I mean, like the fine tuning problem in cosmology is really hard, but if you have to tune not only the electromagnetic wave spectrum, the neutrino spectrum, the gravitational wave spectrum, it's basically hopeless, is it not?
Well, there's a lot that has to go right, for this to work out. But even if it doesn't work out, even if they show up and they do physics in some mind-boggling way that makes no sense to us, then we still learn something. Like in one scenario, in Daniel's Christmas scenario, we learn about the universe because it turns out that the way the things we've learned about the universe are universal and we can share knowledge and build together. But in the other scenario, we learn that the human lens we've used to view the universe has contributed to our understanding or distorted it somehow. That part of our theories of physics are not just the universe, they're our experience of it and our way of thinking about it. And in a scenario where aliens show up and they aren't perfectly aligned with us, then we learn about that human lens, right? And I always got into physics because it was universal and I thought I was asking these big questions. Though, personally and honestly, as time goes on, I feel a little bit like, that's cool, but it's also impersonal. Like nothing I do can help anybody. It's not relevant to life on Earth. But as I was writing this book, I was feeling like, what? It would be actually kind of cool if aliens show up and they don't do physics the way we do, because then we'll learn about humanity. And it turns out that our physics is telling us something about the human experience and the human mind and what it's like to be human and alive in this universe, not just deep questions about the universe. So I think it's a win either way. If the aliens show up and we get to learn about the universe, amazing. If the aliens show up and we realize that we've been making some assumptions and looking at things too narrowly and they blow our minds, and we realize, oh my gosh, there's another way to do math or another way to do science, or they've gone well beyond our process of science that they think is super primitive or something, then we'll learn something about humanity. And I think that would be maybe even a greater revelation about, what it's like to be alive in the universe. So I'm looking forward to the aliens arriving either way.
So one, kind of semi-alien technology that's with us right now is artificial intelligence.
Yeah.
You talk a little bit about it in the book as well. Curious, we can talk, shop and they say when amateur artists get together, they talk, about impressionism Japanism versus Cubism versus the this and that. And when professional artists get together, they talk about where to get cheap turpentine and, horsehair bristles. And so we can talk, over lunch, maybe a little bit more technically. But how are you using AI, both in your physics research, in machine learning? You're one of the early pioneers, in my social network, so to speak, 10 to 15 years ago, using advanced machine learning. But, and this is another one of those things that is sort of the magic of the square root, because 99% of the advanced mathematical operations in machine learning, or at least in LLMs, is diagonalizing matrices,
right?
And you do L decomposition as well as anybody, and so it's basically taking square roots of matrices, right? So there's another instantiation of the square root.
Yeah.
But tell me, how are you using AI in both research and teaching and writing and podcasting?
Oh yeah. Well, I have been doing AI in particle physics since well before it was cool. That's true. And
ChatGPT -7. Daniel, was there?
No, I use, more machine learning than LLMs. We have vast quantities of data, and a big challenge in analyzing it is knowing how to reduce the dimensionality of that data. You measure 100 million things about a particle collision, but it really can be projected down to like a one-dimensional surface in a hugely high-dimensional space where all the useful information lies. And that can be challenging. Physicists can approximate that. We use our intuition, our knowledge, like, oh, I think I know how to do that. And we've done it effectively for years, but it turns out not optimally. And so mostly my machine learning work is like, well, let's figure out how to optimize that, how to extract that another 10%, another 20% out of our data. But more recently, it's been a little bit more transformative. Machine learning has also taken problems that were once intractable, that we've basically given up on.
Right.
Not where we've found an approximate solution that can be optimized, but we were like, yeah, nobody's ever going to do that. And now with machine learning, we can tackle some of those problems. I'll talk about that in my lecture today, about, finding kinds of things that we were blind to before. And now because of the power of machine learning, we can probably see these things. And so it's a great tool. It's a great assistant to analyzing our data, to looking for new stuff. Incredibly powerful. For me, it's a lot of fun because it's essentially applied statistics. And you know that if you work on these huge collaborations, you're not a jack of all trades where you like build the accelerator and the detector and operate it and analyze it and write the papers and do the statistics. You're a specialist. And so my role is like the machine learning, the statistics, the data analysis. I think that's kind of stuff is super fun. That's my flavor of nerd. And so machine learning is wonderful because it's basically applied statistics, and I'm all into that. In terms of ChatGPT and writing and stuff, I'm a big proponent of not doing any of that.
Oh, really?
I think that writing is thinking.
I'm sorry, Chatty. Sorry that he said that, honey. I'll get rid of him as soon as we can.
And that it's really important to develop your own voice and to learn to write effectively. So much of my job is writing. Even if I wasn't writing books and podcasting, it's grant proposals, it's papers, it's emails, it's lectures. It's all about expressing yourself. And it's so important to learn to do that and to develop your own voice, to be able to write in a compelling way and clearly, and to know when writing is good. So right now I'm teaching a class. It's scientific writing for undergrads. How do you analyze data? How do you tell a story about it? And I feel like if we just outsource that to ChatGPT, then number one, everybody's going to be writing the same very bland, boring to read kind of text. Nobody's going to develop a voice, and people are going to lose the ability to do the magic of science, which is like to take a bunch of data and tell a story about it. That's the scientific process. We're always telling stories. And if you lose the ability to tell those stories, or you lose interest in reading them, then I don't know that you're really doing the science anymore. So I'm kind of a Luddite.
Just to push back with requisite love and respect. I mean, some people made similar arguments about the word processor. Some made similar arguments about the typewriter. Just you're taking the person out of it. You're taking the humanity out of it. It's going to lose its soul.
But the typewriter doesn't take the human out of the equation. Huh?
Well, it differs.
Still writing all the words.
You go back to the original writing. It's cave painting, and then you go back to telling stories on scrolls, on parchment, then the codex, then So I mean, there is mechanization, things that made things easier. Spell check. I mean, there's another one. Autocomplete. Things that we take.
Big fan of spell check.
Yeah, me too. That's right. And of course, there's always some attendant emissions. You refine petroleum to make fuel. you have unwanted emissions, and we, kind of distill our social network into, for-profit algorithms. We get unwanted rage and all sorts of other things. So there's a lot of unwanted effects, I'm sure. Even just, speaking physically, the use of AI LLM to do a search is like 9 times more energy intensive than to do just a simple Google search. But, I don't think we're going back to not doing any kind of search. Obviously, looking it up in the library is going to cost something, but maybe not as much as a Google search. So where does it, what uses? So it sounds like you're not, personally using it, but like I do feel like with my students, I encourage them to use it. For example, as an always on demand teaching assistant, I think I'm a good teacher, but if they had Einstein, available to them to ask questions about relativity, and it was fully embodied AI, robotic AI, I'm sure he's going to do better than me. Maybe not as good as the best teachers, but I do feel like there's a huge opportunity. And I did a panel last night with a bunch of undergraduates here at UCSD, along with Adam Bergasser and Ethan Nadler here at UCSD. And I asked the students, like, what are your professors allowing you to do with AI? I also asked this to my friends at Princeton on Tuesday.
Okay.
And they're like, we don't let them use it. I'm like, that's crazy to me. To me, it's like not letting them use a computer or use Python or whatever it was 10 years ago. This is their new reality. So how do you let them, or what, knowing that you want to keep the kind of soul and of the writer and stuff like that, which I can agree with. How do you encourage them to use it and actually apply it?
Well, I tell them to be very skeptical. I treat ChatGPT the way I treat a potential collaborator. Somebody comes to my office and we're talking physics and they say something that I know is totally wrong and they're very confident about it. And I'm like, I don't think that's true.
CMS guy. Just kidding.
Then I'm like, I'm not sure I'm going to ask this guy another question. Or if somebody BS's me confidently several times, I'm like, your information is worthless because I have to check it every single time. I can no longer believe you. So I know people like that in physics, and they're just like sort of off my list of people I'm interested in talking to, or authors like that. I'm like, I'm not reading that because you have to look up everything. I don't believe you. And so ChatGPT is in that category because I've asked it questions about stuff I know anything about, and I'm not impressed with what it says. And so I can't trust it on anything I don't know anything about. And the same is true for a learner. They go to ChatGPT with a question, how do I do this math? How do I factor this polynomial? How do I do this? And they have no confidence that they're going to get the correct instructions.
It's not, they say, this is the worst AI is going to be, right? Right now is the worst it's going to be, and it's evolving rapidly. I think there's actually an underlying issue that nobody's really considered, which is that I don't think LLMs are the pathway either to AGI or, super intelligence, or even to doing useful things in physics, because they're basically trained on language, which is great. And and physics is a language, and aliens speak it, as a best-selling author, professor, and all-around genius, Daniel Whiteson asserts. But who's to say that, we tried with one of my brilliant undergraduates, Evan Watson here, I tried to just give it Mercury's data from its perihelion advance from the last thousands of years from JPL horizons, and then say, like, can you come up with a Riemann tensor? Can you come up with curved space-time as a description of, it couldn't do it. We had to add in like a grid coordinate system and make it into a GPU like thing, that the way LLMs and GPUs were designed to make you better at Minecraft or at, kind of beating your friend in GTA 6. Yeah, maybe it's bad now, but like it sounds like you're kind of writing them off like the crazy uncle you don't talk to at Thanksgiving. Like, how can they get back potentially into your good graces, these collaborators that are unreliable?
Well, like my crazy uncle, the door's always open, and you don't write off family. There could be a moment when they achieve something, and then they're impressive and they can contribute. And I'm not saying that's impossible, but certainly they're not there now.
But if we don't train students now, are they going to be kind of forsworn off in the future? Like, is it going to be, I'm not saying you're doing them a disservice, but just for the sake of the argument,
sure.
Is it kind of like handicapped compared to, Brian Keating's wonderful students who use it every day, in class? I'll say, here's a spectrum of hydrogen, tell me what the Lamb shift is, or tell me, here's the, and like, I don't expect them to know, relativistic quantum mechanics as a junior, but they can kind of glean insight. Well, there's a systematic error there because of projection effects or thermal effect that they wouldn't have thought of. So are they, do you worry that like not training your kids or your students, who are kind of like our kids in some ways, in a beneficent platonic way, but how is it possible that we can train them for the future that's going to exist and we don't even know what it's going to look like?
Yeah, no, I think students should experiment with it and play with it, but they should understand what it can and can't do. And I also think there's real value in teaching students to do the work that ChatGPT, even if it became exceptional, still does. Like, why do we teach students to do integrals? Why do we teach calculus in high school? Like, Mathematica basically solved that problem. You throw any integral in Mathematica, it's done. Why should we teach anybody how to do integrals? It's because we're training them how to think. And we're hoping that they go on and surpass us. And we don't want humans to lose that capability, in my opinion.
Sure.
And so there's lots of things that are sort of solved problems that we still ask students to do. And I think it's important and valuable for them to do that as a way of training them and teaching them these critical thinking skills. We're always telling physics undergrads, you can do a physics major and then do anything. And that's because we've taught them these tools of thought, these tools of analysis, these ways to think about problems that let them go off and then eventually become, podcasters and cosmologists and all sorts of things. And so I think we do them a disservice if we don't teach them.
That's my racket. I got to corner to the market.
We do them a disservice if we don't teach them those fundamentals of thought. And we just like throw the LLM at them. But you're right; they need to be aware of it and know how to navigate it and use it. Absolutely, they need to be familiar with it. But I wouldn't rely on it as a teaching tool.
Sure. I mean, it hallucinates and a sycophanty, which I love. I mean, I bring on the sycophanty for the brilliant Professor Keating. Or make it call me, hair professor, senior Keating. I asked it, like, what books is Brian Keating? I used to Google myself. I'm not going to say if you did or not, but I used to Google what's going on with Brian Keating? And now I, chat GPT myself. All right. And it comes up with, what books has Brian Keating written? Well, he's written Losing the Nobel Prize. Okay. He's written Into the Impossible and Galileo's Dialogue.
And do you have a Grokpedia entry?
I do.
Congratulations.
It's 20 pages long.
Wow.
But then it says, after Into the Impossible, Focus Like a Nobel Prize Winner, now available, as you know, on Amazon. We'll put the ad in for that here, by the way. It says, Brief History of Time. And I'm like, that would be nice to have, 1% of those book sales, but unfortunately I don't have. So there's rumors that there'll be an AI data center in space in the coming years, which made me think of, let's say one of those goes rogue and we have, HAL 9000 up there and it just, now it decides it's going to blast its way through the wormhole around Proxima Centauri B and check that out. So it's going to be an alien artificial intelligence, maybe in a physical embodiment, a data center, Oumuamua flying through space with a bunch of NVIDIA hoppers on it. but maybe it's just the pure AI, coursing through the space. And maybe that's the alien that we come into contact. Well, what do you suspect? I mean, it's certainly cheaper than sending meat chunks around the galaxy, right? So what are the odds that the aliens that we encounter will be artificial intelligence, pure code?
Yeah, it's certainly possible. And it's tempting to imagine that that's inevitable because it seems the direction of our civilization. But I also think that that's short-sighted, that we're always, taking whatever we developed in the last 10 years and imagining that dominates the universe. Yeah. And much more likely there's something even more mind-blowing that in a million years a civilization develops in a way that would be like hard for us to even think about. But like imagine explaining AI to Isaac Newton, right? Like what words would you even, how could you possibly even do that? So we're so primitive, I think, compared to those other civilizations. But like AI data centers in space never really made sense to me because everything is harder in space. Building it, repairing it, cooling it, everything is harder in space. To me, AI data centers in space only make sense for AI in space and built in space. So if you have like a space industry and you have power needs in space and data center needs in space, sure. But for use on Earth and like built on Earth and launched to space, that doesn't make any sense to me. I don't see how the numbers work out.
I mean, I think they're saying things like power requirements, and because the latency is not such a big deal. I mean, I wait, 10 minutes for a query to come up, like what has Brian Keating written in addition to Brief History of Time? Soon we're going to take you up to the faculty club to fetch you as you deserve with an all-you-can-eat salad buffet. But before we do, I do want to talk about a little breadcrumb for the audience to stay tuned to the channel because we're going to have a technical talk. But as Daniel is almost unparalleled at doing, he has a way of explaining it even to fellow physicists in a way that a simple experimental cosmologist can understand. So that'll be a talk. I'm going to preview that in just a minute. But before I do, I mentioned losing the Nobel Prize. The Nobel Prize figures very prominently in this book, also published by Norton, which was publisher of my first book. And the Nobel Prize is sort of seen as this talisman, as this anchor that, aliens can help you win. Maybe I think I'm permanently off the list after my first book. But we have invented not the Nobel Prize, but the Keating Prize.
Oh, look at that.
This is the Keating Prize for impossible wisdom.
Wow.
And this, let me see what it says here. There we go. So the Keating Prize is hereby presented for Impossible Imagination, featuring a picture of Arthur C. Clarke, a monolith, and it is presented to Professor Daniel Whiteson, October 31st, Halloween. Here you go, Daniel.
gosh.
Thank you so much for coming down.
I should have worn my tuxedo. I wasn't prepared.
You should have brought the book. That's all I wanted you to do, Daniel.
should have.
You had one job, literally. Okay, let's talk about the tech talk we're going to talk about later on today. So this is a very interesting, kind of a topic that seems to suggest that even classical electromagnetism, we talk about quantum mechanics and stuff, but even some aspects of the application of electromagnetism to particle detectors may be wrong or may involve new things. I don't know if quark was meant to be a particle or it might be meant to be a quark. So tell us, what is the topic? First at a lay level, and obviously people stay tuned for the technical talk later on, which we'll have on the same channel in a separate episode. But tell us, what is a quark? What are these different features that physicists might be getting wrong? And first, begin with, how do normal particle accelerators work?
Yeah. So this talk is about an example of what I mentioned earlier, where machine learning can help us do things that were impossible before. And so the way we see particles currently is we smash the particles together and then they fly out and they pass through layers of detectors that leave little hits that say a particle went through it, a particle went through it. So we don't see full paths of particles. We see these little traces that they leave. And then we're left with the combinatorial problem of I have 10,000 traces, probably due to 1,000 particles. How do I know which was which? How do I reconstruct the particle paths from the traces that were left? And that's a very hard problem because there's lots of possible assignments. This one, that one, the other one. It's 10,000 choose 1,000 is a big number. Trying them all is impossible. And so we have tricks. And a lot of the tricks we've used help us solve the problem more quickly, but also blind us to possible solutions. So one trick is, for example, to assume that the particles are all charged electromagnetically. Either they're neutral, in which case they're invisible anyway, or they have positive or negative charge, in which case they move like a helix in our magnetic field. And so you can say, well, I'm just going to look for helices. Cool, because most particles are helical in their trajectory. So that really simplifies the problem, makes it tractable. We can process all of the data at the Large Hadron Collider. But what if there's a particle that doesn't just have electromagnetic charge, it has some new weird charge, some dark matter charge, and it moves through the detector in a weird path that's not helical? Our algorithms would not find it. They would skip right over it. And amazingly, your algorithm would find it. If I printed out that event and showed it to you, you'd be like, oh, I see that. Because your brain is really good at finding tracks. Yeah. And it used to be that we used humans to do this back when we didn't take a lot of data and the signals were obvious and you could just put them in front of ladies.
The computers were women.
Yes.
Literal.
Exactly. Yes. Humans doing this. And now we can't afford to do that because we take data every 25 nanoseconds and it's too much. So we developed an algorithm to find particles that don't move as a helix using machine learning. And one example of that is the quark, which is a great example of physicists taking an English word that means something else and just giving it a meaning in physics, which is terrible, like work, right? Or color or flavor, all these things.
Beauty, charm.
Yes, exactly. But a quark is a particle that has a new kind of charge on it. And if you produce them in pairs in the colliders, they don't move in a helix. They oscillate with really strange trajectories. So it's just one example of a non-helical path. And so in the talk today, I'll talk about how we found an algorithm that can find quirks, and then how we generalized it to develop an algorithm that can find any smooth path at all, even if it's unexpected, unanticipated, unpredicted, for which there's no simple explanation. Because that's my dream, is to run this thing on real data and have a shocking surprise and be like, what is this thing in our data that nobody'd ever seen before because our algorithms we're blind to it. And it could be like a single particle, one particle, one Nobel Prize. That's the classic ratio, the positron, for example. The Higgs boson, when we discovered that, it took billions and billions of collisions to get a few examples. But there could be obvious, no background, single event discoveries waiting for us in the data.
That already exists.
That already exists. They're sitting in the data right now. That if we only knew which event to look at, we could print it out today and look at it right here live on camera and make a discovery. But we don't have the algorithms, or didn't until now, have the algorithms to find those things. So that's what I'll be talking about.
Are you also involved in the technical sense, looking for, conserved quantity? Is there something analogous to weak isospin, to lepton number? Would there be a new quantum number associated with the quark?
Perhaps, yeah. Or, if we find something even weirder, My goal is not to find something that makes sense. It's to find something that doesn't make sense. I want to find something then I take it to our theory colleagues and they go, no, it can't be. We proved that can't be part of the universe. I'm like, well, but the universe says it is. So what are you going to do with it? That's the fantasy where it's a struggle to incorporate it, because you and I both know that our theory of physics is incomplete. Fundamentally so. There's a foundational layer we have not cracked, and we don't know where is going to be the clue that cracks that. Is it going to be people working on string theory? Is it going to be people, looking into the stars? Or is it some new particle we produce at the colliders that when we tug on that string, everything unravels and reveals the truth? Right. We don't know. So, but, swing for a home run. That's my plan.
That's right. Well, I'm feared for your safety now, because people are trying to, build bigger and better colliders, the future circular collider, the large linear colliders, the collider on the moon, and all sorts of other things. And now they won't need it with the Whiteson algorithm. They'll just go back to the archival data. And it seems like you could apply it to any data, right? It could be from the Tevatron. It could be anywhere. So that's amazing. Yeah. So that would obviate, the pork barrel spending with, luckily, for your safety, there's not a huge danger of somebody spending a lot of billions of dollars in this climate. But
I'm a big fan of spending money on big science projects. People say you don't need the next collider, but I say you don't know.
Your thoughts on the next collider?
I say you don't know, and I think it's a mistake to say, is it the next collider or this other project? I said, let's build them both, right? It's not an either or. Science and economics are not zero sum. Right.
Well, how do you react to, our mutual friend Sabine Hassenfelder has been very critical of plans to build things whose purpose is not exactly as well maybe motivated as the Higgs was even, which, took AST years before its discovery. What do you say to critics that, you shouldn't spend money on something in the case that you might find it? And there are a lot of projects that do that, including my projects. Right?
I think exploration is valuable. I don't think you need to know what you're going to find before you look. We don't go to Mars just to look for like cats and dogs. We go to Mars to find something shocking, something surprising. And we hope that our tools have the capacity to discover surprises. That when we go and land the Europa Clipper, it's going to find something super duper weird. So I'm a big fan of research as exploration and not making promises in advance about what we're going to find, because you never know. And that's the joy and the frustration of research, right? What do I say to critics? I say that these things are valuable, that research spending always returns in terms of aesthetic benefits of understanding the universe, economic benefits of the technologies and the transformational ideas, educational, cultural benefits. Every dollar we spend on this stuff is worthwhile.
Returns more than $1.
Yeah. And I think that people can reasonably disagree about how to spend limited research budgets, and that's fine. And other people welcome to have ideas and think that our ideas are silly, and that's fine. But we have a process for that. We get together, we review them, and I think that process is flawed because we're human, but it's done in good faith. And I think that's where I disagree with some of your friends. And I still think most people out there are curious scientists doing their best to understand the universe and operating in good faith, even if they don't agree with some folks about what the best way is to uncover the secrets of the universe.
Oh, I pointed out to my good friend and UC Riverside Professor Barry Barish that he would not have won a Nobel Prize had the Superconducting Super Collider not been canceled, because he was working on that.
I see.
And maybe he would have stayed with it, but because it got canceled, he was able to work for LIGO. And because he worked for LIGO and led LIGO, he helped LIGO achieve a Nobel Prize for not just himself, but Kip and the team and Ray Weiss, the late great Ray Weiss. So I think that, you have to kind of always be on guard. As I say in my first book, serendipity is hard to plan on. But this is a delightful book. Can't wait for your lecture. We'll broadcast the lecture on the channel at a later time. We're going to get the episode out about Do Aliens Speak Physics, with the very terrestrial, very always illuminating and fellow, it's rare that there's so many people that do, theory, and theory's cheap. I always say experiment is expensive. Theory's kind of like software. You can make much of it if you want. It's not AI slop, but you can make it's hard to make a lot of experiments, as we know, right? Yeah. Daniel Whiteson, UC Irvine, thank you for this wonderful book. People check you out on Twitter, on the podcast, Daniel and Kelly Explain the Universe.
Extraordinary Universe.
It was Jorge. Yeah, I'm never, primacy of learning. And of course, Do Aliens Speak Physics. Thank you so much for coming down.
Thanks very much for the fun conversation.
All right, let's go get some faculty club lasagna or whatever they have today. Thank you, Daniel.